Hello, I'm Ward Ramsdell, electrical design engineer and co-owner of Prototype Engineering. Today we're going to be using the MDO4000 series to look at the turn-on characteristics of a 2.4 GHz power amplifier, for which I have the evaluation board here. Our test setup is going to consist of an arbitrary waveform generator, a power supply, and the MDO4000 instrument. And what we're going to be looking at is the characteristics of the amplifier in both the time and frequency domains as it's turning on. This is important because obviously there are consequences both from a regulatory and compliance standpoint, but also from a standards compliance standpoint for how quickly the PA turns on. So we're going to be compromising between PA turn-on time and spectral purity. So now we've fully integrated the power amplifier evaluation board into our test setup. We have the arbitrary waveform generator attached to the power amplifier's control line. An RF signal generator is applied to the power amplifier's input. The output of the power amplifier is routed to the MDO4000, as is the PA control signal. So on the scope screen we have an analog trace, which is the power amplifier control line. We have an RF trace, which is the output spectrum of the power amplifier. And we have this bar indicating the spectrum time over which this spectrum is drawn. So you can see that we're now looking at the noise floor prior to PA turn-on. This is before the pulse is applied. We can very quickly and easily pan over and look at the PA in its normal regime of operation. And we can pan back and look at the PA as it's turning on. So now we're looking at the transient spectrum of the PA. This is a really neat feature because it allows you to very quickly and easily adjust what you're looking at using a very intuitive interface. By far the cleanest way I've ever done it. And so now what we're looking at is we're looking at the spectral purity of the power amplifier. So you can see the impact of the rising edge of that pulse and the consequences of that we have some spectral splatter. So what I can do is I can change the rise time of that, and we will change it from, at present, 50 nanoseconds. We'll change it to 100 nanoseconds. A little bit of regrowth there. Now we'll go up to a half a microsecond. And you can see a very dramatic shift in the sidebands further out. There's still some artifacts here. And I'll zoom in the scale a little bit here. And we'll actually go up to 1 microsecond and you'll see a very dramatic shift here. So that fairly clearly illustrates the consequences of changing the rise time. Obviously the PA turns on more slowly, but at the same time your spectral purity, your transient spectral purity improves dramatically. So what we've shown here today is the ability of the MDO4000 to very quickly and easily demonstrate the turn-on characteristics of a power amplifier, both in the time and frequency domains in a time-correlated fashion. I was able to look at the pre-turn-on characteristics of the power amplifier, the standard operating mode characteristics, as well as the transient characteristics, which are of most consequence to standards compliance and regulatory compliance.